The Moon. It is our closest neighbor in the universe, and information on its characteristics can reveal a lot about the rest of our solar system. Also, we are able to investigate the lunar surface in spectacular detail thanks to the LRO spacecraft's eyes. On the western edge, where the near and far sides of the Moon meet, is where our trip starts. The vast structure is a lunar crater called the Oriental Basin. Here, surface gravity readings from the Grail mission are combined with the LA Rose Railway map. This information opens a window into the lunar interior's geologic characteristics by revealing structure in the crust underneath the Moon's surface. The South Pole, where we will next travel, gets little direct sunshine and experiences some of the solar system's lowest known temperatures. Based on temperature measurements from the LaRose Diviner instrument and reflectance from its laser altimeter LOLA, the highlighted locations indicate probable water ice. LOLA has also given us access to Shackleton Crater's darkness by providing us with this digital elevation model. While it is 21 kilometers broad and 4 kilometers deep, the South Pole Aitken Basin, the biggest known impact crater in the Earth-Moon system, dwarfs it. It measures 2,500 kilometers broad and 13 kilometers deep and is located on the other side. The basin was initially observed by spacecraft flying around the far side in the 1960s, but its exact age is still unknown. As much as we explore unknown terrain on the lunar near side using LRO data, we also explore a well-known region to return photographs with a completely new degree of detail. Tycho Crater is shown here. It dates back around 100 million years. This image from the Lunar Reconnaissance Orbiter shows the center peak with the mysterious 100-meter wide rock perched on it. We will eventually reach a region on the near side of the Moon that is excellent for investigation due to the variety of impact and volcanic materials. It has a prominent crater that is so brilliant that it can be seen with the unaided eye in addition to via telescopes. Welcome to the plateau of Aristarchus. Pyroxene, a mineral, is seen in orange in this infrared image, and plagioclase from Aristarchus crater is visible in blue. This area has a wealth of information on the Moon's long volcanic history. We gaze at the Moon in order to choose locations to travel, but we also consider the places we have already gone. This is so that we may better comprehend the sequence of events in early lunar history by reinterpreting the geology of well-known locations using the new data that Aloro is acquiring. The path the astronauts walked over the course of 3 days is displayed here as we approach to the Apollo 17 landing site in the Taurus Littrow Valley, which itself is deeper than the Grand Canyon. The Lunar Reconnaissance Orbiter camera is even able to capture a view of the bottom half of the Apollo 17 lunar lander, which still sits on the surface, as well as the rover vehicle. These images help preserve our accomplishment of human exploration on the Moon's surface. Even the still on the surface lower half of the Apollo 17 lunar lander and the rover vehicle are visible to the Lunar Reconnaissance Orbiter camera. The achievements of human exploration of the Moon are preserved by these pictures. Moving on, we travel to our destination. This place has areas that are almost always in light and areas that are almost always in shade. North Pole is what it is. Scientists can simulate sunshine and darkness at the poles over decades and millennia because to LOLA's precise terrain observation. Future lunar missions may find it useful to generate solar power at these sunny crater edges and mountaintop.